Okay, so how many minutes does it take you to get to school? So this is what we did in class. Is I started off with like 0, 5, 10, 15, 20, 25, 30, 35, 40, and we kept going on and on and on. And then everybody was like, oh, well, some of us takes like 4 minutes to get to school. Some takes like 7, a couple take 10, right? So we'd have like 10 and 15. And that's what we did is we created these, we recorded the data, and this is called a dot plot, where we would put minutes takes to get to school. And then what was weird is that, for our particular class, we had very few, we had not as many students, right, in the class period. So it's really hard to get accurate, data when you don't have very many students. So then it says to go to this, this link here, which I don't know if it'll take me here, but it gives me to the census data. And what I was able to do is I gave the students in class, because we were only on either a phone or a tablet, so it was really hard. So what we did is I went and did the data collection for them myself, and I had like 25, 5, 20, 20, 10, 7, 7, 12, 20, 8, 8, 40, 15, 5, 30, 5, 10, 38, 25, 15, 10, 26, 25, 14, 30, 15, 45, 7, 15, 5, 7, 10, 15, 12, then a random 523, and then 5, 7, 4, 10, 15, 25, 20, 10, 14, 5, and 5. And then what I did is we plotted these, made a dot plot. So, and I guess it wouldn't be in the number. Oh, yeah. So I made a dot plot here. And then, let's see, 5, 10, 15, 20, 25. So I had 1 for 25. I had 1 for 5. I had 2 for 20, 1 for 10, 1 for 7. And so I just kept doing this, right? So we plotted all of these. So I would want you guys to go through and plot all of them. At least plot this data, right? So that you know, like, minutes takes to get to school. And so we did. So do all of these and create your dot plot. Now, we looked at this. We couldn't really look at the similarities and differences because there wasn't really enough data for our class. But when we go down here, I defined quite a few things in class because we have to describe, like, when we compare data sets, we have to look at comparing what we call shape, center, variability, and outliers. And that random, like, 523, that's way out in, like, no man's land, right? It would be an outlier. But there's an actual formula for that. So outliers are, like, I don't know, loners, data points all by themselves. So data points away from the rest. Variability is like the range of the data. The center can be the mean, which is the average. So where you think the average might be, or the median value. Shape, we talk about skewed. So skewed left means all my data points are on the right. Skewed right means all of my data points, like the majority of my data points, are on the left. And then symmetric means that it kind of looks like a frowny face, like a symmetric frowny face, okay? And make sure when you do dot plots, dots of equal size and scale the axis and label the axis, okay? And that is it for the notes for this section.